And you're not gonna have your cheat sheet with you, so you're going to have to just generate it. So asymptote at 0, intercept. So if I had to graph on tomorrow's quiz an actual logarithm, any logarithm, that's what it would look like. All right, what's y equals 1 over x? What's the name of that? What's 1 over x called? The reciprocal function. And what does it look like?
It's got like 1 in quadrant 1.
Yep, so it's got an asymptote, vertical at 0, horizontal at 0, and then is a little hyperbola, as Fred said, in quadrants 1 and 3. X squared, what's x squared look like?
Parabola.
That's a parabola, vertex at the origin, right? Quadratic, x squared. All right, number 2, what function is that? I drew the function. Now you're gonna write the equation of it. So y equals what for A? That's your cosine. So COSX, cosine x. There's your equation. What's the equation for B? Absolute value. Yep, that's your V, absolute value. And then C is 1 over x, your reciprocal function. All right, name a BFF that has an asymptote at y equals 0. Now, I got a couple of them up here, or no, I have one of them up here. Can you name, besides that one, can you name another BFF that has an asymptote at y equals 0? Exponential. Did you cut the line at football the other night? So rude, man. Not a good way to represent Cathedral High School.
Come on.
So the exponential, which looks like this. Right? So that has an asymptote at 0. Can you think of any others? Logistic function has an asymptote at y equals 0. And actually, he has another asymptote at y equals 1. Right? We got this one.
You know how? Do we have to know the names, or can we if they ask for one?
You have to know the names, the equations, and the graph. All right, B. Name a BFF that is bounded below and has no zeros. So bounded below and has no zeros. We got one up here. How about this guy? Is he bounded below and has no zeros? Yeah. He has a 4. He's not bounded, but he's bounded below. How about this one? Is he bounded below?
Yeah.
And has no zeros? This one is not. This one has no zeros. What are zeros? Zeros are x intercepts. So he has no zeros, but he's not bounded below. Name a BFF that is increasing on its entire domain. So we're going to talk more about increasing today, but I think you know what that means. Increasing means as you draw it, your pencil goes up. This is not increasing. How about this one? Is this one increasing?
Yep. Yeah.
Left to right, your pencil's only going up. Now, I don't want anybody to be confused. I know that if I start here, my pencil's going down, but in a conversation about increasing and decreasing, it's left to right. That's how we're moving, okay? as I'm moving left to right, my pencil is only going up. How about this guy? Increasing on its entire domain. Yep, my pencil's only going up. How about this one? Is that one increasing on its entire domain? No. Is it increasing on part of its domain? Not the whole thing. Can you do another one that only goes up?
Linear function.
Linear, and of course if it's linear, it's also cubing because they're basically, they're very similar. So linear and cubing, yep, are increasing on their entire domain. I think, oh, did we talk about logistic? That one's increasing on its entire domain. All right, so those are the kinds of questions you're gonna be asked tomorrow.
We need to turn that in.
No. Nope, your job was to finish that up and hopefully study it a little bit. All right, let's get our notes out and let's start in with 1.1. Attendance real quick.
Way too many.
No, 37. He's been saving his time. I'm on board.
This is for,
Oh, yeah,
do you have an extra note, or notes packet and homework packet?
I might back there in the thing that says honors. All right, here we go. A what is a mathematical relation that maps a set of input values to a set of output values such that each input value is mapped to exactly what output value? What do you think? Can you fill in the blanks? Function. This is the definition of a function. And input value is mapped to exactly one output value. Yep. One. Each input has just one output. In previous courses, you may have used the vertical line test to determine if a graph is a function or not. We're gonna learn in Unit 3 that that isn't always the case. So just kind of keep that in the back of your mind, that the definition is your focus, not necessarily the vertical line test. The set of input values of a function is called the domain, and it is represented by the independent variable, independent. Again, in Unit 3, we're switching to a different coordinate system. So we gotta quit thinking about domain as x. I know in the Cartesian coordinate plane, x and y, I know x is domain, but don't define domain that way. It's the independent variable. And the output variables are called the range, and they are represented by the dependent variable. The dependent variable. All right, so for these x's, we are going to draw a picture of the function that has the inputs and then adds one. What would that equation look like? The function f halves the inputs and adds 1.
X over 2 plus.
You guys need to keep those for tomorrow.
Oh.
Keep them. So 1/2 x plus 1, does that sound about right? Bye, Olivia. Alright, so let's graph it. Half of 0 is 0 plus 1. Half of 1 is a half plus 1 would be 1 1/2. Half of 2 plus 1. Half of 4 plus 1. I'm kind of skipping here because I know this is going to be a line. Half of -2 is -1 plus 1. Oh wait, no, -1 plus 1. Half of 1 is -1, -1/2. Plus 1 is +1/2. 4 would be -2 plus 1. Did you get some kind of little line segment like that? So what yours look like? Is that a function? Yeah, because every x I plugged in gave me exactly 1 y. Vertical line test works. Alright, how about B? Now we have a table of values. And a table of values just represents a bunch of ordered pairs, right? So -4, -1, -1, 2, 0, 3, 2, 3, and 4, 1. I have no idea what that's supposed to be. But is it a function? Yeah. Yeah. Should I connect the dots? No. Because what am I plotting? Table values. Now why did I connect the dots over here? I needed all the x's between -4 and 4. Here, I only need the x's in the chart. Okay, this bottom thing here is so important. We've already talked about the first two, increasing and decreasing. Increasing means as I draw it from left to right, my pencil is going up. The formal definition says if A is less than B, then f of A is less than f of B. So in other words, as the x's increase, so do the y's. Remember, f of A is a y. And then decreasing, same thing, only as x's increase, y's decrease. Now, this notion of concavity may be something that you've never really thought about, although when you did polygons in geometry, you probably talked about concave polygons. Look at the picture for concave up and concave down. Does that make sense to you? Concave up means the cup holds water. Concave down means it doesn't. But here's the important part. The rate, if a figure is concave up, its rate of change is increasing. Its rate of change is increasing. If a curve is concave down, its rate of change is decreasing. That has nothing to do with being positive or negative. It has to do with increasing or decreasing rate of change. All right, so with that in mind, let's look at the picture. Use this random figure to find open intervals where H has the following behaviors. Now again, don't be confused. This little chart over here talks about a function increasing and a rate of change increasing. Those are two separate things. So where is the function increasing? That's what question A is. Where is the function actually increasing? What intervals? Negative 2 to 0? Yep. It's going up. We're talking about the function, not the rate of change. We're talking about the function. Any place else? Declan?
4 to 7.
What?
4 to 7.
4 to 7? Any place else that the function is rising? Okay. Where is it decreasing then? This was increasing. Where is it decreasing?
-4 to -0.
-4 to -2. Okay, any place else? 0, actually 0 to 4. Isn't it going down that whole time? Where in the picture are we concave up? Oh.
Sorry about that.
Where are we concave up?
2 to 7.
2 to 7, concave up, 2 to 7, very good. Where are we increasing and concave down? Increasing and concave down. Good job, -2 to 0. And where are we decreasing and concave up? Let's see, decreasing and concave up. What'd you say? 2 to 4. You guys are amazing at this. Now we're gonna find out how good you are. Take a minute with your partner and create a graph based on the information that you've been given. And then we're gonna have a couple of you come up and put your ideas up on the board.
Like 5-7 would be like a doesn't go all the way.
Well, is it saying that like 7 there, or is it saying like there's no 2 Because like up here.
There's more than one option, by the way, that's why I'm gonna have more than one individual do it.
Didn't you just put? I think it's.
No, you're good.
I don't think it's just points. I think it's like, yeah, intervals is like only exits. So I don't think it matters what we're close to one.
That's the gap between the two. Because if that ends, or that starts right there.
Yeah, so it'll go up, down, up, but then
Additionally,
it's concave up on the interval.
Wait, oh my gosh.
We have to go back But it has to be -4 to 3. It's hard to see.
Well, it could be like, it could be like, it just has to start, it could be like that.
All right, let's get a couple ideas up here. Right? You'll do it, because you always do it. You're amazing.
Locked it.
You got one? And don't copy off each other. Just use, put down your idea, because, they're probably both right, but they hopefully look a little different.
Wait, oh, I need to fix something real quick.
Okay. All right, let's look at the black one here first. What do you think about this? Is it increasing from -4 to 1? We need to be careful with that. It looks like you. Okay, now it's going up. All right. And it's increasing from 5 to 7. Just keep it going. Okay. Decreasing from 1 to 5. Okay, that's definitely going down. Concave up from 3 to 6. Yeah, that looks concave up. Okay. Concave down from -4 to 3. Okay. And 6 to 7, yeah, that's concave down, good. Yeah, so how's that look now, is that okay?
I thought they were points, not intervals. That's why mine looks weird.
Alex,
Yeah.
the graph of K is increasing on the interval. Okay, so, I don't know, this is a good picture here, right? Everybody okay? Alright. I always put in supplemental stuff. You may or may not do all of it. I want to look at the back of the, how does the food industry set prices? The back of that page, yes. Because I want to talk about interpreting the graph in real life. The graph below gives the food company's revenue for baby formula. The x-axis is the price of the formula, and the y-axis is millions of dollars revenue. Does each equal increase in price change the revenue by a constant amount? Why or why not? No, why not? How do you know? Absolutely. It's not a line. If the y's and x's were growing proportionally, we would have a line. So very good. All right, a new intern suggests selling the formula for $20. Is this the best price? What do you think? Okay, why not?
Because it's not the highest that you can go.
Exactly. You could sell it for a higher price and make more money, right? So, no. The next guy suggests selling it for $80. No. What should you sell it for?
60.
About $60? Because as you've indicated, that's the highest revenue. At what price will the company make no money on the formula?
Like 118.
0, you make no money. Obviously, if you don't charge anything, you're not gonna have any revenue. And then what happens at 18 or whatever that is?
Not getting any sales.
Not gonna get any sales because it's just too expensive, right? When or why might companies use factors besides revenue to determine their prices? Like, think about this for a second. This is baby formula, okay? The company could charge, what did we say, $60? Would that always be what a Holy Cross company would want to do? Doesn't $60 seem a little bit high?
Yeah.
And what happens if you overprice it? Then all of a sudden,
Babies can't.
yeah, and then you got babies can't eat, or you got moms trying to economize, mixing it with too much water or something, and then the babies aren't getting enough nutrition. So yeah, there are always social factors that you have to consider. All right, let's look on the next page. Easton is going to the bank, and then to the grocery store, then he goes home. How long does the trip take him total? 75 minutes. Everybody good with that? Remember, what's y? The distance we are from home. So if that's 0, it means he's at home. So after 75 minutes, he's at home. How many minutes is Easton at the grocery store? About 15 minutes? How did you figure that out?
Because he took a stop at the bank from like 20 to 30 minutes, and then on his drive to the grocery store, there's another break up top, and it's from 40 to 55 minutes.
And what does that horizontal line mean, that break up top there? What is it? He's not getting farther from home. He stopped, right? He stopped somewhere. On which time intervals is D decreasing? 55 to 75? And what does that mean? If D is decreasing, then what's going on? He's getting closer to home. He's on his way home. At what time is Easton exactly 1 mile from his home? As close as we can get it. I don't like the word exactly 1 mile, but looks like when?
12 minutes.
About 12 minutes. And then again at
67.
67, 68, something like that. All right, number 2, this is another one, see if you can come up with a picture. Anybody got one you're willing to share? That one? Perfect. Who else? Let's get a girl. Ella? You got a thought on that picture there? You can bring a partner. You don't have to do a solo if you don't want to. Oh, let's use the black one for that. Okay. Eamon's x-axis is a little concave down.
Sorry.
Oh, they have pretty much the same picture. How does that look for the rest of you? There was no, mention of concavity in this one. It was all just increasing, decreasing, or constant. Perfect. All right, last page. What is the business cycle? This graph shows how gross domestic product changes with respect to time. Number 2, at each of the points A, B, and C, determine if the GDP is increasing or decreasing. So what do you think about A? Increasing. What do you think about B? Decreasing. And C? Decreasing, right? Now, the max and min values are called peaks and troughs, okay? Label them on the graph, okay, so you can see where the peaks and the troughs are, right? What can you say about the rate of change at those points? So at the top of the hill, the bottom of the valley, what can you say about the rate of change at those points?
0.
It's 0. Very, very good. Those points are called maximums and minimums. And the rate of change, think about this for a minute. There's a maximum. The rate of change is slope. Okay, rate of change is slope. Right here, at this point, what is the slope of that line at that point right there?
0.
0. The rate of change is 0 at that point. The rate of change is 0 at that point. All right. is GDP increasing and decreasing at a constant rate? No. Do I have concavity? Yeah, I have curvature. And when you have curvature, you don't have anything constant. The only time you have constant things is when you have a line, right? At point D, GDP is increasing, okay? Is it speeding up or slowing down? At point D. Slowing down. How do I know? Okay, wait, there's a mathematical reason. Yes, you're right, but there's a mathematical reason.
Since it's concave down.
Concave down. What does concave down mean? The rate of change is decreasing. So if you are anywhere on a concave down portion of the graph, your rate of change is decreasing. When is GDP changing the fastest? Well, we haven't talked about this yet. It's changing the fastest. Okay, so let's look at some of these pictures you guys drew. Now, would you say that this part of the graph is concave down? And this part of the graph is concave up? This point right here, where the curvature changes, remember the other day I was drawing a cube and I said this part of the cube is concave down and this part of the cube is concave up? That point where we go from being concave down to concave up is called a point of inflection. And that is where your rate of change is the fastest. That is where the line, the tangent line is the steepest. That is where the rate of change is the fastest. Right here at the point of inflection. The rate of change is the fastest at that point. So, can you tell on the graph, none of our labeled, well actually, point E kind of looks like a point of inflection. Would you agree with that?
Yeah.
Point E, I think, is the point of inflection there. There are a couple of others in the picture, but they're not labeled. At point E, is the slope of the curve negative or positive? What does this mean in the context of the problem? At point E, the slope is negative. What does that mean in the context of the problem? The GDP is going down? How, point B says, how do you know, what do you know about how the GDP is changing at that point of the business cycle? Point E is where it is decreasing the fastest. That is bad news. It's decreasing really, really fast at that point. Describe what is happening at point F with as much detail as possible. Okay, what's happening at point F? What's the GDP doing? Increasing. Would you say it is increasing at an increasing rate or increasing at a decreasing rate?
Increasing rate of change.
Increasing rate of change, so it's increasing at an increasing rate because F is still part of the curve that's concave up. So that means its rate of change is increasing. All right, turn it over. You and your partner need to read the quick notes and then do the check for understanding. We'll talk about them in a couple minutes. Make sure you read and understand those quick notes.
There was lawyers. Yeah. The one guy myself.
The rate of change is, but it's still well, the next one has that rate of change, so
It's still increasing, but the slope's increasing, the slope's positive.
Just content that gets
well, since the slope is positive, because sometimes you need positive, like here, the slope is
no, well, yeah, roll it up. One point seven.
so this is talking about the rate of change, where it goes, yeah.
Years? Let's just do like 3.5.
We just need the X value, so. This one half.
This could be about well, but then this one.
One to three, basically. It goes past like 3.7.
Reflection. Oh.
So he's first one we would want. Well, actually, it's 0.5.
Where you at?
It was like 3.
Well, I would say rate of change, that's just slow.
Because it's a point of
And so
inflection.
0.5 that has to be the biggest.
Why didn't we choose, so like, why didn't we choose this point instead? So the point is, yeah, because this is the point that switches. This, yeah, here separates one.
It's not the rate of change.
And this is the rate of change. trying to come from like a city down.
So like,
I don't know what her something will change.
Yeah. Cool. Which bug?
Alright. Is that increasing or decreasing at x equals -1? Increasing, and how do we know? Slope's positive, we're going up, slope's positive, very, very good. Is the rate of change increasing or decreasing at -1? Decreasing, and how do we know the rate of change at -1 is decreasing? It's concave down. So this is where you really have to keep things straight in your mind. The curve is increasing, but at a decreasing rate. It's going up, that means it's increasing, but it's concave down, so that means at a decreasing rate. On which interval of the domain is the graph concave down? What did you say?
-1.9 to 0.7.
I said -2 to 0.5, but we have to approximate, right? So are you in that ballpark, everybody? How about concave up? I used 0.5, so I said from 0.5 to 3, but you would have said from 0.7 to something. Estimate the x value or the point of inflection. Well, what? I said 0.5, but you probably said 0.7? Yeah. So somewhere in here, right, is a point of inflection. Now, tell me what you came up with for the rate of change. Remember, rate of change is slope. So you had to match up these black points. Tell me the slope at these black points. So what did you say for -1.5? You put 4 here? Alright, what did you say at -1? What? 1. What did you say at 0? And at 0.5? -3. Okay? And then what's left? Here you put what? 9.75. Alright, let's talk about that. First of all, does anyone disagree? Alex?
I would put 9.75 where 4 was, because that has the, like, that's increasing more than.
So, first of all, these have to have positive slopes, right? And these have to have negative slopes. And it's kind of hard from my picture, but it looks like at 2, we are just on the upward thing. So we have, of our possible choices, we have 2 negative slopes and 3 positive slopes. So I think we got those in the right spot. But, what's this right here? That's a minimum. And at a minimum, the slope is 0. This seems a little high to me. Alex said that he thinks this one should be the 9.75. Does that make sense? Very steep slope there. All right, and then what did you put down here, Alex?
I put one down there or where the other one is.
All right, let's talk about that. His logic, I think, was that we're just barely moving off of 0 here. That point is almost the minimum. So he said, I think that's just barely moving positive, so I'm gonna get that 1. This is a little steeper, not as steep as that, so I'm gonna make that a 4. Okay. Declan?
I have negative 4.25 and negative 3 foot.
And why was that, Declan?
Because negative 4.25 was a point of inflection, so it would have a high rate of change.
That would have to have the biggest rate of change, right? When in doubt, think about a tangent line. If I draw that tangent line there and I draw that tangent line there, can you see how that one, Fred, is way steeper than that one? So the tangent line is a slope. That's the direction of the curve there, that's the slope. So that is clearly much higher than that, so that makes sense. Same thing here. All right, okay, 1.1 will be due on Thursday, and we have a quiz over your BFFs tomorrow. So if you haven't done those, please get those things learned. Flashcards.